Hi guys, this is Miss Scott, and today we are going to learn about section 5.2 in geometry. So here's your bad joke of the day before we get started with that. Want to hear a joke about paper? Well, never mind, it's terrible. Okay, so here we go. Section 5.2 is about perpendicular bisectors. So if you want to pause the video and jot this stuff down, then we'll talk about it for a little bit. Alright, so now that you have this written down, first thing is we're going to answer the question, how do you find the circumcenter of a triangle? So a few things we need to know about is, first of all, a perpendicular bisector is just a segment, line, or ray that intersects the midpoint of a segment at a right angle. So for example, a perpendicular bisector is like if you have this segment and then you have a line that's cutting it into two equal pieces, and then this right here is a 90-degree angle. That's what a perpendicular bisector looks like. A point of concurrency is just where three lines or rays or segments meet. So I might have this segment and this ray and this line. They would all meet at this point right here, would be the point of concurrency. So it's just where three things intersect. The circumcenter, we'll draw a picture of that in an example down below, so don't worry about that for now. We'll come back to it. And then a circumscribed triangle is if you have a triangle, like so, and then you draw a circle that goes through the three vertices, this right here would be a circumscribed triangle. And then equidistant just means the same distance away. All right, so let's look at some examples here. First thing we're going to do is put a point C on the perpendicular bisector. And it doesn't matter where we put the perpendicular bisector as long as it's on this vertical line here. So I'm going to put point C right there. All right, then what we're going to do is draw in using a ruler. So I have this handy dandy ruler tool here. We'll make these pink. I'm going to connect from that point to point A, and then from that point C to point B. And then what you're going to do is measure the length of those. So if I get out my ruler and measure this top segment on the left, I find that this is about 3.2 centimeters, just based on where I drew C. Yours might be a different length, so do measure it. It might change depending on where you put point C. And then this over here I measure, and I get 3.2 centimeters. So over here I'm just going to fill that in. AC and BC were both 3.2 centimeters. So that actually leads us to our first theorem. You probably noticed that these two lengths were equal. So it turns out that if you have a point on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. All right, and we can see that from this example here. And that actually works both ways. If we would have started with that point C and we knew that the point is equidistant from the endpoints, then it has to be on the perpendicular bisector. So that theorem works both ways. That's what the converse means. It means you just switch the if and the then. Okay, so now let's actually get into that third vocabulary word. In our next example, we're going to figure out what this word circumcenter means. So what we're going to do is draw the three perpendicular bisectors of the triangle. So how I do this is I actually get a note card, because I know a note card has a right angle, and I line it up to create my perpendicular lines. And if you're not sure what I mean by that, you can come find me. I can show you an example, and I think you'll get the hint. But here we go. So we're actually going to start this the same way that we created the mid segments in the previous video. We're going to measure the lengths of these sides. And it turns out that this is actually the same exact triangle that we used in the previous section. So I actually, again, I went ahead and did this ahead of time. I measured that length there, and I got 6.2 centimeters. So we're going to start by finding the midpoint, which for this one would be at 3.1 centimeters. So each of these would be 3.1 centimeters if that's the midpoint. And I also found the length of this side was 6.9 centimeters. So if you cut that in half, you get 3.45. So measure 3.45 centimeters out and put the midpoint there so that each of these is 3.45 centimeters long. And then lastly on the bottom, I measured this length ahead of time and I found that it was 8.6. So you need to measure and put 4.3 centimeters. The midpoint's going to be there. And then this side would also be 4.3 centimeters. Okay, so now what we're going to do is draw in right angles. So again, if you use a note card, it makes it kind of easy to do to make that right angle. You can line up your note card. And what I mean by this is, let me actually get a rectangle here. Actually, I think I can make a rectangle with that. So pretend this is your note card. What you can do is you can move that and you can turn it and then put it so it lines up with one of the sides. And now there's a right angle. Whoops, I'm gonna move that up a little bit. So like this, you're doing this with a note card. You're lining it up at the midpoint. So you have a right angle right there. And then you're going to draw a line. And I'll do these in this bright blue color so we can see. You're going to draw a line through that point so that it's straight along that note card. Because what you just did then is you created a right angle right here at the midpoint of that segment. So we would call this a perpendicular bisector, this bright blue line. Okay, so we're going to do that again. So I'm going to turn my note card so that it lines up with this bottom side here. And I'm going to line it up so it's straight with that and then put it at the midpoint. And again, I need to move that a little bit to the left. We want to make sure we do this accurately so that things match up where they need to. And then we're going to draw a line straight flush with that note card. And it doesn't matter if you go past the triangle. Whoops, get rid of that. I have to erase this. Okay. And then let's move this. Uh-oh, my midpoint went away. Okay, let's just get this out of the way. Alright, we're just gonna try that again. Okay, so I don't know why that second line showed up there, but we just need this line. Okay, there, that's better. Okay, and let's get our note card out of there. Again, this is going to be a right angle here, and then we're going to do that one more time on this third side. So I turn my note card so it lines up with that side, put it at the midpoint, and then draw this straight line through there. Okay. And again, this makes a right angle here. And now what you should notice is that those three perpendicular bisectors intersect at that point right there. Okay, we call this point the circumcenter of the triangle. So it's the point of concurrency of the perpendicular bisectors. All right, so let's get this out of here. So now what we're going to do is we are going to label the triangle ABC. So I'm going to say this point here is A, this is B, and this is C. And then we're going to call the point where the three perpendicular bisectors meet point P. And then we're going to measure the distance from A to P, B to P, and C to P. So use centimeters just to make this a little more accurate. I'm going to get this line segment. So draw a line from A to P, draw a line from B to P, and then, oops, I don't know why that did that. B to P, and then lastly, a line from C to P. And what you're going to do is measure each of those segments as accurately as possible. Now, I did this ahead of time, but I'd like you to pause the video and give it a shot. But I found that this right here is about 4.3 centimeters. This right here was 4.3 centimeters. And this right here was 4.3 centimeters. So it turns out that that point, which again we call the circumcenter, and it is actually equidistant from each vertex of the triangle. So if you want to find a point that's the same distance from three other points or places, that circumcenter actually does that. That's mathematically what the circumcenter does. So it's kind of nice for some word problems, which we're going to look at the end of this video. So next thing we're going to do is use this fact to answer some questions. So go ahead and flip to this next example. And we have, find the value of x and tell what theorem was used to set up the equation if line CA is the perpendicular bisector of segment DB. All right, well right here, they're telling us CA is the perpendicular bisector of segment DB. So we know this has to be perpendicular right here. All right, and we know actually that theorem 5.2 tells us that point C is on the perpendicular bisector. So if that's true, so we know C is on the perpendicular bisector. So it's the same distance to from point C to B as it is from C to D. So we know CB has to be congruent to CD. And if that's true, if this is the same length as this, well then what we can do to set up an equation is say that 10x minus 4 is equal to 4x plus 14. So let's go ahead and do that. And then we can use our awesome algebra skills to solve this. I'm going to start by subtracting that 4x from both sides. So we end up with 6x minus 4 equals 14. Let's go ahead and add that 4 to the other side. These will cancel. We get 6x equals 18. And if we divide by 6, we can see x will equal 3. All right, so we found the value of x, and we found that theorem 5.2 was the theorem that we used. Okay, so let's do one more example using that next theorem. So they tell us in this figure here, the circumcenter of triangle MNP is 0.0. All right, find the length of the following. Well, if you remember from that theorem that we did, theorem 5.4, we know that the distance from O to M is the same as the distance from O to N, and that's the same as the distance from O to P. So this length, and this length are all equal. Well, they told us that ON was 26.8. So OM also has to be 26.8. All right, and I'm actually going to skip ahead to OP because that also has to be 26.8. So these three segments are all 26.8. All right, so now let's look at the other segments. The next one is MP. So that's this length here. Well, we know that these are the perpendicular bisectors, this segment OS and OQ and OR, which means S, Q, and R are the midpoints. Well, if this is 22 here, this has to be 22 here. So we can see from M to P has to be 44. And we can use that same idea over here for PR. Well, we know R is the midpoint because it's the perpendicular bisector. So from P to R has to be the same as this. So it's also 26. And then we're going to use this to find the perimeter. So lastly, we know that Q is the midpoint up here. So these both have to be 20. So let's add up these three sides. From M to P is 44. From P to N is 26. If you double that, you get 52. And then lastly, from M to N is 40. So if we add those all up, we get 136 for the perimeter. And we don't know the units, so we'll just leave it as generic units. Okay, let's look at our last example for today. This one is a word problem. And it says, the new manager of La Crosse area Jimmy John's is trying to find the best place to rent a house. She wants to live about the same distance from each of the locations. Use the map to find where she should start looking for a place to live. Okay, so the first thing that I'd like you to do is just pause the video and then write down these three steps. So when you look back in your notes, you know what you did to solve this problem. So we know that the circumcenter is the same distance from 3 points. So we have to create a triangle in order to construct the circumcenter. So the first step here is to make a triangle using those three Jimmy Johns as the vertices. All right, so just connect those with a ruler. Make sure you use a ruler. Okay, and then the next thing we're going to do is construct the perpendicular bisectors. So what you need to do is measure just two of the sides. You can do this with just two, and it'll still work out. So you have to measure and find the midpoint. So I did this ahead of time, and I found that the midpoint of this side was right here. So it made that side equal to that side. And then I found the midpoint of this shorter side was right here. So that gave me this was equal to this. Okay, and again, you can get your note card out. So your note card will help you find your perpendicular bisectors. And we're going to take that note card and spin it around so that it's lined up with one of the sides. It doesn't matter where you start. And then we are going to draw in this line. Okay, and I'm going to keep going a little bit here. I need to move this so I can extend it. So you should always extend your perpendicular bisector outside of the triangle, because sometimes it does end up being outside. All right, and then let's spin our note card around so that this is now our new right angle, and we line it up with the midpoint. And we can draw our other perpendicular bisector so we get those two to cross. Okay, now this point where they crossed, let's do that in blue, they intersect right here. So that's at the circumcenter, and it turns out that if I measure that distance to this Jimmy John's, and that distance to this Jimmy John's, and then to this one, it will be the same distance to those three. So she'd have to drive the same number of miles to get to each of her places of work. So this is where she should start looking for a place to live, somewhere in this general location right here. All right, so you can see how this is useful. Okay, well, I appreciate you guys tuning in. Let me know if you have any questions. Feel free to comment below, and we'll see you guys next time.